Alright guys, so welcome back here. This is the second video for lesson 4.6, example 3. So same example, same company, office company here. Suppose that we know the cost function, the annual cost of manufacture X paper shredders for the office supply company in problem 2. And that equation is 90,000 plus 30x. We want to find out what is the company's maximum profit, what should is charged for each shredder, so that way the company use or has the maximum profit. And then we also ask to find how many shredders should it produce, and then the price per shredder to have maximum profit. So this is slightly different from the maximum revenue. Because to get the maximum revenue, to get the most profit, you want to maximize revenue, you want to minimize the cost here. But in this problem, it's asking for what is the maximum, the company's maximum profit, at how many shredders should it produce, and also how much charge per shredder. So if the function we're looking at is a profit function, we have to construct that. We have to find what that is. But we do know that profit in general is equal to the revenue minus the cost function. So that is P of X. So now we can define a profit function based on X. So the revenue function, we found that already from the previous video, and that function is the revenue. So we have 300x minus x squared over 30. We're going to subtract that to the cost function, and that is given in this example, and it's this one here. All right, so let's go ahead and subtract the two function to get the profit function. All right, so that will give us, let's see here, P of X now equals 270x minus x squared over 30 minus 90,000. Okay, so that's our profit function. To maximize the profit, we have to find the critical value for the first derivative. And to do that, we get 270 minus x over 15. So that is the first derivative function for the profit. Set that equals 0. So we have 270 equal x over 15. So therefore, x is 270 times 15. And if you do the math right, you should get 50, I believe, 4,050 shredders. So we can use the second derivative to show that this will give us the maximum again. But just quickly, the profit function is an open downward parabola. So this is a concave down functions already. So we can test what we did in first function to show that the second derivative of the profit function is negative. Therefore, it use a concave down function. Therefore, this point here will use a local max or relative max here. So you can verify that on your own there. So we can say that at producing 4,450 shredders, the company's P of 4,050 shredder will give us a maximum profit. So that would be, what is this? So 270 times 450 minus 450 squared over 30 minus 90,000. So if you do the math right, this is going to come out to be $456,750. So this is the max profit. So at 4,550 shredders produced, the company will have maximum profit of, max profit of 456,750. Okay, and then it's asking for how much should the company charge for each shredder. So to do that, we're gonna plug in this here to the price functions, because the price demand function relate between x and p. So that was 300 minus x over 30. So we're looking at x is 4050 over 30. Okay, so if we do that correctly, let's see what we get here. So we got 300 minus 4050 divided by 30. So we're looking at $165 per shredder. Okay. So if the company's charged, if the company produced 4,000 50 shredders and set that or charge $165 per shredder, the company will yield the maximum profit of $456,750. Okay. So these are the three answers we're looking for. Okay. All right. $165 per shredder produced at 4,050 shredders will yield a maximum of $456,750. Okay. So we can actually write. I guess we can write a quick interpretation there. So the company will have a maximum profit of 456,750 when producing 4,050 shredders and charge 165 per shredder. Okay, so that should be it. That should be the interpretation of this problem here. Okay. All right, so I'm gonna go ahead and end this video, and I'll do another video on the next example here. So this example 4 here should help us do example 5 and 6. So I'm gonna do example 4 very thoroughly here. Let me go ahead and end this.